I'm Galen Winsor, and I thought I'd share a few hands-on practical things that have to do with this nuclear scare scam. Now, you've heard that gamma energy, the kind of energy that comes off a rock like this, is the most penetrating, most damaging of all radiation. And not only that, here is uranium, the parent of radon, and they say if you can detect radon in a home, then it's bad. If you exceed the EPA's limit, it's reason to run you out of your home. Spend $13,000 like they did with Stanley Watrous' house in Pennsylvania the other day to get rid of the radon, to ventilate it out through. Ridiculous. Let's take them one at a time. This is a rock that I picked up in Natarita, Colorado. 16 weight % uranium. High-grade uranium. Hot. I read a thing the other day that says they had high-grade uranium, and lo and behold, it's too hot to transport, so they had to bury it on site. Oh, wonderful. Let's talk a little bit about radiation. If we can, yeah, are we picking up? If you put the probe right there, the meter goes off scale, and you can hear it, all right? Hot. Radiation, gamma radiation, is the most penetrating of all radiation. Oh, is it? All it's got between the rock and the probe is my hand. Doesn't count so pretty much, does it? What if I put the rock behind me? You don't suppose they've been lying to you, do you? I suspect they have. Well, let's do a little bit more. I got a black bottle. This stuff comes in white bottle. A bottle of no-dose. You can send children down to the drugstore to buy no-dose. All they need is money. In this are 660 white caffeine pellets. And this one is uranium oxide, U3O8. You can't buy it for love nor money. The state of Washington sent 2 of their Gestapo agents over to my home to confiscate my uranium samples on the 17th of December last year. Got a challenge. I'd like to have somebody in the room volunteer to take all of this bottle or all of this bottle. The only thing that I'll tell you is that one of them won't hurt you and the other one will kill you. Do you want the white stuff or the black stuff? White stuff? You do. There's enough in there to kill 4 men your size. The government says we got to ban this material. It's radioactive. Let's check it in the bottom of the bottle. Not very radioactive. Let's take the cap off. Oh goodness, very radioactive. This instrument will only count gamma, energy. It's just energy. Light's coming from those lights, only you're getting lots of infrared from the lights as well as ultraviolet. Energy response, and it's very carefully damped to only discriminated so it only gets the energy that comes from this. I don't want it to respond to a light, just to this. Cost me $1,000 to get an instrument that will just respond to this and not to that. This is radioactive by any definition. Radioactive material giving off radiation that is read by an instrument like this. The daughter of this, radon, cannot be read on this instrument because it gives off alpha particles. An alpha particle is a dye-positive particle that comes from the nucleus. It has 2 protons and 2 neutrons, therefore an atomic weight of 4, and it's minus 2 electrons. And if you grab it with a high ionization potential counter, it'll count. But if it travels 2 inches in air or through a piece of paper, it picks up 2 electrons, 2 beta particles, if you will, and becomes helium gas, and it won't count on an ionization chamber. Did you know that this thing right here is giving off helium gas? Alpha comes from uranium. Okay, radioactive material. You pour it out in the hand, and that's radioactive contamination. Is it radioactive? Yeah, it is. Very radioactive. Now, decontamination is nothing but scooping it back up and putting it into the bottle. I just now decontaminated my hand. No, I didn't do such a good job. Not good at all. Is it still radioactive? Yeah, that's called residual radioactivity. Now, under the decontamination rules of the government, when you decontaminate somebody like this that's that contaminated, and this is certainly a reportable incident under current DOE regulations, when you decontaminate him, it has to go down a controlled drain so that you don't disperse radioactivity. Do I qualify as a controlled drain? That material that I just ate is not soluble in body fluids. Like it's been this. It was fired at 940 degrees C, where it becomes U3O8, known in the industry as HCl insoluble. In other words, it will not dissolve in concentrated hydrochloric acid, hot. Your stomach has 10th normal hydrochloric acid in it, so it won't even dissolve. The stuff is so fine that it has no texture to it. Doesn't even feel rough. So it's tasteless, odorless, has no texture. How's it supposed to hurt me? Because I've been eating this on lecture tour for 2 years, the state of Washington felt it necessary to confiscate my uranium samples so that I would be safe. Dr. Fulton from the Hanford Environmental Health Foundation called up and he says, "Hey, I heard one of your guys OD'd on uranium today, Galen." And we talked for a little while and he says, "Oh, that was you." And I says, "Listen, I can eat all that stuff I want." He says, "It'll ruin your kidneys." "How are your kidneys?" "They're fine." "Well, you should have been chelated within 4 hours. And I mean, you guys are going to follow me around the country and give me chelating agents every 4 hours after I eat it on lecture tour?" He says, "We'll give you any medical assistance that you need, Galen. We don't want anything to happen to you." I said, "Did that include turning out the federal SWAT team 4 days ago to get me?" Where are these guys coming from? Well, here's a piece of metal. Density of 19.0. If you know your chemistry and physics, you know that there are only 2 metals that have that density: plutonium and uranium. Radioactive, pyrophoric, density of 19. Outside of a laboratory, most of you can't tell me whether this is uranium, plutonium, or a mixture of the two. Now, I said that it's heavy, and it is. Let's see if it's radioactive. Yeah, it is. Pyrophoric, what does that mean? Pyro, fire. Black on the end. The spark that just came off there is pyro, fire, burn. If it's plutonium, I just contaminated this area of Arizona in excess of the EPA's limit for 1 square mile of surface. Somebody laughed. It's serious. The end of progress altogether says that I just contaminated you in excess of the limit for 1 square mile. It's now silver on the end. Tomorrow it'll be black because it self-oxidizes, this black color like this, all by itself. Plutonium does that and uranium does that. Is it hazardous? Yeah, it is, because they take depleted uranium metal and make it into 50 caliber bullets, fire them from shoulder-held weapons. In 1976, they obsoleted tank warfare with these things because it only takes one dog face with one weapon to knock out a 65-ton tank. It'll go through 3 inches of armor plate, and when it comes out the other side, it's that white hot spark that we just made. And the 5 men in that tank are dead because it'll burn all of the oxygen out of the air and burn their flesh. 1976, they obsoleted tank warfare, and you never even knew that. They make 10,000 of those bullets every day in the United States. We got enough in arsenal to sink all of Russia's tanks, and our boys in the Defense Department don't even talk about it. Yeah, it's hazardous to your health. Reminds me, lead is hazardous to your health too, isn't it? Particularly if it's in a 45 slug like this and it hits you right here going about 2,600 feet per second. It's not the material, it's the impact from the velocity. Let's be very specific in the words that we use. This particular chunk of lead came out of a human body. My son, who's a deputy sheriff, thought maybe I could use it on tour. That's called dying of lead poisoning. Anything less is a figment of the imagination because it's not soluble in body fluid either.
On the 11th of March 2011, following a massive earthquake and tsunami, a nuclear accident occurred at the Fukushima Daiichi power plant in Japan. Radioactive material was released into the environment over several days. The Japanese authorities took precautions to protect the public. A 20-kilometre exclusion zone was set up, and restrictions were imposed on the consumption of products grown around the plant. But these actions only seemed to add to the mood of public anxiety and confusion, fed by a global media frenzy. The common assumption was that many Japanese people would suffer long-term cancers from the radiation. As for the workers still at the plant, they were seen as dead men walking. But with the eyes of the world on Fukushima, an important anniversary was taking place, one which offered lessons on the public health impacts of nuclear events. It was the 25th anniversary of Chernobyl, the world's worst nuclear accident. UNSCEAR, the United Nations Scientific Committee on the Effects of Atomic Radiation, was set up by the UN General Assembly in 1955. For the last 25 years, it has examined in detail the impact to health and the environment of the Chernobyl accident. UNSCEAR's principal officer is British scientist Dr. Malcolm Crick.
After Chernobyl, the only public health impact that we've seen has been the more than 6,000 thyroid cancers amongst those people who were children at the time of the accident, drinking contaminated milk. Of those 6,000 or more cases, perhaps 15 had died. It's not a very fatal disease, thyroid cancer, if it's caught early and treated properly. Then when we think about other effects, actually there's no really good persuasive evidence of any public health impact due to radiation from the accident other than the thyroid cancers. Most people find that kind of hard to believe, but in fact that's the case.
Professor Jerry Thomas from London's Imperial College is a world authority on molecular pathology. She's also a director of the Chernobyl Tissue Bank, an international initiative to collect biological samples from those exposed to radioactive iodine in childhood. Work that has led Dr. Thomas to reassess her views on nuclear energy.
Just in case. The health consequences of a nuclear power accident may not be as bad as we first thought. I was anti-nuclear until I started working on Chernobyl. Now, no problem at all.
The results of the studies that we carried out post-Chernobyl, which were big international studies, have not been what we might have expected from the outset. Those studies have shown that there is only one thing that we can pin down to being due to radiation, and that's the sharp increase of thyroid cancer in those who are very young at exposure to the Chernobyl accident.
In the case of Chernobyl, there was a lot of iodine being released, and, very important, nobody told the population that this iodine was there and that the milk was contaminated with this iodine.
Professor Abel Gonzalez from Argentina is deputy chairman of the International Commission on Radiological Protection, a body of the world's leading scientists and policymakers, which, since 1928, has set guidelines for governments around the world.
Mothers who didn't know that an accident has happened, these mothers were given contaminated milk to their children, very heavily contaminated milk. Not surprising, the children have a very high dose of radiation in their thyroid, and not surprising, a lot of children, mainly in Belarus, but also in Ukraine and in Russia, got thyroid cancer that can be attributed to Chernobyl.
If we think of the emergency workers after Chernobyl, there's 134 people who got acute radiation sickness from the first few days of very high exposures after the accident. And 28 of those people died. They died within the first month or so. Then when we look further on in time, those people have got problems with skin injuries still, and they've got problems with cataracts. But only about 19 or 20 people have died in the period since the accident to now. And not all of those deaths can be attributed to radiation. In fact, many of them clearly are not due to radiation.
So the voice of leading scientific bodies is clear. The only observable public health impact due to radiation after Chernobyl has been the more than 6,000 thyroid cancers, of which only around 15 have proven fatal. As for the emergency workers who received the highest doses, fewer than 50 have died. These numbers, while significant, represent a fraction of the hundreds of thousands, if not millions, of victims predicted after the accident. Frequently misunderstood by the public, radiation dose is determined by the type and amount of radiation we are exposed to. It's measured in the International Standard Unit of millisieverts. Professor Thomas on the doses received by residents living around the Chernobyl plant.
Now, this is the figure that when I saw it thought, well, actually, that nicely puts it into perspective. The whole body doses to 6 million residents is about 9 millisieverts, okay? So each person got about 9 millisieverts. And 80% of that lifetime dose was delivered by 2005. Now, 9 millisieverts is about what any of us will get when we go and have a CT scan. Do we sit there and panic about having a CT scan? No, we don't. And we need to make sure that we keep that in mind when we're talking about accidents like this. We expose ourselves to radiation voluntarily. We can't avoid it. We live in a radioactive world.
Naturally occurring background radiation is the main exposure to radiation for most people globally. Levels typically range from 1.5 to 3.5 millisieverts per year. However, there are several places in India, Iran and Europe where doses can be more than 50 millisieverts a year. Medical procedures such as X-rays account for most of the remaining 12% of a typical person's annual dose. So, what of Fukushima Daiichi?
In real terms, I doubt there'll be any radiological consequences to the whole population at all.
The second big impact of Chernobyl was the famous thyroid cancers on children. And this thyroid cancer has happened because the children were drinking contaminated milk. Well, this is not the case in Fukushima. I mean, the mother's nose and children were not given contaminated milk. The milk was controlled. Therefore, we should expect basically not a thyroid impact in Fukushima.
By comparison with the frontline workers tackling Chernobyl, the safety provisions were very different for the Fukushima workers.
They were very well protected. They have very proper clothes, they have a record of doses, they have control.
Now, they have had higher doses of radiation than the population outside, but they're an order of magnitude less than the doses that were received by the firefighters and the helicopter pilots in Chernobyl. So I think it's highly unlikely they'll suffer any long-term consequences going forward with the doses that they probably received.
So, thanks to measures taken by the Japanese authorities, expert opinion is that we can expect no health impact on the population around Fukushima due to radiation. As for the workers at the site, they too can expect to avoid ill effects from the exposure they received. So, if the health consequences are not what they're commonly believed to be, what are the consequences of a serious nuclear accident like Chernobyl?
When we think then about the non-radiation impact, clearly this has been a tremendous trauma for the people in terms of the stress and anxiety and concern that the radiation environment has caused them, and the countermeasures that have been made that have disrupted their lives.
Chernobyl was a real catastrophe for the people of the region. They changed the politics of the region, they changed all the social infrastructure, they changed all the economy of the region, but was not a health impact. What the media have been saying about that were simply wrong statements produced by misinformed people.
In the confusion and disruption that follows a nuclear accident, the social and economic consequences become far greater than those relating to public health. So what can be done?
Well, I think the scientific community has to do a much better job at communicating to the public or to the lay person. Decisions are being made all the time on fairly important issues that relate to the understanding of this science, and I think the understanding is hindered by the quality of the communication that we, the scientific community, have given in the past. And I think we've got to do a better job at this. We have to have this in our programs of work for the future. Some really thoughtful consideration of how we communicate better, rather complex ideas to the public and decision makers so that they can really assimilate and appreciate what we are talking about.
I don't think we should blame the media completely for what happens. Scientists have a responsibility as well. It's important to be able to get a public understanding of the science of a situation like what happened in Fukushima out there, so that the public can make a judgment for itself. And if nobody is willing to talk to the media on the science side, or a government representative, for example, being put up who understands the science and can answer the questions, then that feeds people's fear. Communication is actually extremely important in a disaster like that. And if communication had been better post-Chernobyl, if communication had been better post-Fukushima, maybe we wouldn't have done the psychological damage that we appear to have done to those populations.